Okay, for these last 4 application problems, make sure you still have a Desmos open. And remember that before we go identify the trig function, set up the equation and solve it, we have to draw a diagram. For any time we have a word problem, we need to visualize that right triangle that we need to use right triangle trig to solve. So Juanita was flying a kite at the park and realizes that all 500 feet of string are out. Margie measures the angle of the string with the ground with her clinometer app, we all have that, right? And finds it to be 42.5 degrees. How high is the height above the ground? So picture anytime we're talking about a height above the ground, that we're talking about an angle of elevation. What is an angle of elevation? It's somebody who's down on ground level. So here they are down at ground and they are looking up. So she used this clinometer app to measure that the angle is 42.5 degrees. So that's our given angle. And they said something about the string of the kite, right? So picture this kite going up and that's 500 feet long. But they want to know how high it is from the ground. So here's our right triangle with the given angle of 42.5 degrees, the hypotenuse of 500, which is our kite string, and the missing height happens to be our opposite. So which trig function are we going to use? You got it. Opposite over hypotenuse is going to be our sine function. So we're going to set this up. The sine of 42.5 is equal to the opposite over the hypotenuse, multiplying by that denominator. We're going to go plug in 500 times the sine of 42.5. And that gives us 337.80 feet. So the kite is 337.80 feet off the ground or above the ground, however you want to say it, approximately. Okay, pause the video, you try the next one, see if you can draw the image. Neil's kite has a 350-foot string. Oops. When it's completely out, Ian measures the angle to be 47.5 degrees. How far would Ian need to walk to be directly? So this time we're talking about him walking here along the bottom. So we're talking about the adjacent being the missing piece this time, not the height. So this time we're going to be using adjacent in the hypotenuse. It's our cosine function. Cosine of 47.5 degrees is equal to adjacent over hypotenuse. Multiply by that 350 to both sides. Plugging into our calculator, 350 times the cosine of 47.5 is supposed to be a decimal, hang on, 236.46 feet. How far would you need to walk? Ian would need to walk approximately 236.46 feet. How'd you do? Okay, pause the video, you try it, let's see how you did. Using a clinometer, Tamara measured the angle of 11 to the top of the pole. So again, here she is down here, looking up at a pole. So the flagpole is 15 feet high, and she measured an angle of 11.3 degrees, and the tamara is 62 inches tall. How far from the flagpole is she standing? So we're trying to find this distance here. So if they're telling us how tall she is, there's got to be some little distance here of where she's standing. Yeah, I don't like this one. We're going to ignore that part because that just makes it confusing. And we're just going to pretend like she's standing here at ground level. Okay, so going for this missing thing, please don't worry about that 62 inches tall. We're going to use the adjacent and the opposite this time. Which trig function uses opposite and adjacent? This is our TOA. So tangent of 11.3 degrees is equal to opposite over adjacent. Notice that since we're going for a variable in the denominator, we're going to multiply both sides by x and then divide by the tan. So 15 divided by the tan of 11.3 is 75.07 feet. So we would say Tamara is 75.07 feet from the pole. Last but not least, she's now looking at the sighting on the top of the flagpole from a different position. This time the angle is 58.4 degrees. If everything else is the same, how far? So still how far? So we're still going to use opposite and adjacent. This is still a TOA. So the tangent of 58.4 is equal to opposite over adjacent. So we're really just going to be dividing 15 by the tan of 58.4. So 15.53 feet. Notice she got closer. By having a steeper angle, looking up steeper, 58-degree angle, she got closer. At 15.53 feet away. And remember that that's approximate. How'd you do? All done.